I'm excited to talk today a bit about Rust and JavaScript. It's the perfect pairing, combining the two. There's absolutely nothing that could go wrong, and that's what I'm going to talk about today for about half an hour. It'll mostly be code, but yeah, a bit of an introduction at the beginning. So yeah, I'm Jakob. I'm a Rustacean since around 2016. I'm currently spending most of my time developing a sort of a dance app. You can find it on my GitHub if you're interested, but that's not what I'm talking about today. The thing is, the app does use Rust and JavaScript combined. So the way it works, it's a Svelte UI. So the user interface, everything you see is done with JavaScript and Svelte. But everything in the client state, all the logic, all the code that is kind of more than just the user interface, all of that is in Rust. And I tried to build this architecture and play around with it. It was mostly, yeah, that's the one. Well, that's the website. I think the app right now is probably down. I got a pager notification on my Telegram, but I'm not home, so it's not working right now. But you can check it out anyways, if you want. It started as a hobby project, turned into something I'm pursuing a bit more seriously right now. That's why I sometimes freelance, because right now I don't really, because I work more on the project. But yeah, I'm freelancing as well if that's something, like if you need something specifically around Rust and JavaScript, I'm always open to talks around that. But yeah, that's kind of why I even talk about that. And before we jump into the code, I assume everyone in here knows Rust and the basics of that, so I will not talk about that, and I will not explain to you how perfect Rust is, because it is perfect, and it's impossible to write bugs with Rust. We all know that. But you already know that. I don't have to explain that. But wasm-bindgen, by show of hands, how many of you have used wasm-bindgen before? I want to say about 2/3 of the room. So for the benefits of the others, I will quickly say, like, what does it do? Why do we need it? So wasm is WebAssembly. You can use Rust, compile it to WebAssembly, and it can run anywhere where you have a WebAssembly runtime. Most notably, browsers have a WebAssembly runtime. So you can take Rust, compile it to WebAssembly, and run it in the browser. You don't need wasm-bindgen for that. Just WebAssembly as a target when compiling works. However, wasm doesn't have like a nice interface for objects. You can only pass around numbers, and things are pretty annoying if you try to do everything by hand. That's why you can have wasm-bindgen that generates all the bindings that you need to make the communication between Rust and JavaScript easier. And what you see in the generated code is mostly kind of extern, C, and then something. If you have done any sort of Rust plus another language, then you've probably seen this. As soon as you want to have something exposed through the linker that's kind of outside the Rust world, you say it's extern and use the standards defined by C. Even if you're not using C, that you use that standard, and then you define your functions and whatnot. All of that gets generated by wasm-bindgen, and we don't have to worry about it. Also, all the unsafe code is hidden from us, and we get a nice and safe interface. You get a couple of automated type mappings as well. That's always nice. For example, strings in JavaScript are encoded differently as they are in Rust. And moving from a string that's allocated by malloc or whatever allocator you have inside Rust, and then combining that with a string that's managed by the garbage collector of your browser, like, it can be a bit annoying if you have to do all of that by hand, but it's just automated with wasm-bindgen. You just pass through a string, and it's a string, and it's fine. And you can define your custom structs and enums, and wasm-bindgen will make it easy to kind of use it from the JavaScript side, and don't have to worry about how is it serialized on the API kind of when sending it back and forth. And there's a bit of Java side initialization code. If you really like to write that code by yourself, you can use like the compile and load and kind of like these browser API functions that let you take some wasm code and run it. If you just have wasm-bindgen, you just get a JavaScript file and you load that and it just runs.
So you, anyways, question?
Yeah, if you have a question.
So you have to decorate your main or something? And
Yep. Yeah, we will see a lot of code afterwards and you will kind of see how that works. But that is basically the tool we are using and yeah, what it brings us. And that's pretty much all the slides I have. Now we go to the code and we will take it from there. And yeah. Thank you. Okay, yeah, I've mirrored screens, so that should work. I hope it's big enough. So the first thing, before I jump into the code, let's just look at how it looks. So let's open the demo, and I will explain first without code what we are doing here. So we'll have like a toy project, right? It's a demo, it's some kind of a bot detection. The idea is I can move around my cursor, we record all the movements of the cursor, and then I can click. Maybe I need to make it slightly smaller so we can see the whole thing, but you can probably still read the important parts. So if I click on am I bot down here, it will tell me, am I verified as a human or is it maybe a robot? And there's some debugging down below, we will see it afterwards. But the idea is pretty simple. We have this user interface that's JavaScript, and then in the background, we feed all the mouse events into Rust code, and the Rust code can do some more interesting computation, and then go back and tell us. And I will show you, before I even show you the code, I show you this perfect implementation here. Kind of move my cursor around. Let me see which version this is before I do too much. I might need to rebuild. I think this is good. Yeah. You know, I'm a bit. I don't want to show you any bugs on the first page. That would be a bit embarrassing when I say it's impossible with Rust to make any problems. So let's just refresh this page and click here, am I bot? Null pointer pass to Rust. Wait, that's maybe that button isn't the best to click. Maybe I should click this one. That seemed to have worked somehow, and this one as well, okay. But now I clicked it twice, and now again null pointer pass to Rust. Yeah, something is not working out. And I'm even a bit confused why the first button worked, but that's probably fine. Let me. So we can debug this together, right? So when I'm moving this cursor, what's happening? We go kind of the stack down the way the data passes. So we will start with the JavaScript code. Let's make it like this. Left side is Rust, right side is JavaScript. And we have the on-mouse event here. I can highlight that. Okay. So it's really just these two lines, or like 3 lines with Windows, on mouse, we set this event. This is JavaScript, how you register an event globally on the window. Then we have this detection object that I'm going to show you how it's created a bit afterwards, but this is like our Rust state. And we add an event in here. We pass some data in here. It's like a timestamp. Date now gives a nice Unix timestamp. And we give this event that's from the event handler. That's just browser API has a defined event. And then we set this all events thing right here. And now I'm already kind of one step ahead. So this is like great demoing mistakes. So if I did a mistake here, but I undid the mistake, and I click here, I get the null pointer on this one as well. And if I click here, I get an interesting different error. Error contains a value of the wrong type. And really, what I want to show you here is like we get some weird kind of errors that we wouldn't quite expect. Especially because this is not JavaScript code going wrong. This is Rust code generating a panic, wasm-bindgen catching this panic and converting it into an exception on the JavaScript side that we can catch. We have on the JavaScript side here, let me just reset this. I have this show error function that I wrap around most things. It takes a function as an input, it will execute this, and then it will catch whatever error was thrown and shows it kind of in this. It just basically replaces the entire body with just a message, kind of like things went wrong, delete the website. Here is what you need to see. But it also prints the same error to the console. So if you open the debug console, you can see this exact same error is here. And if I didn't catch it, it would just be an uncaught error here. And you can see it's at, maybe I can zoom in a bit. So it's wasm-bindgen throw. So this is, again, wasm-bindgen catching this panic for us and then throwing an error. And we can kind of get a backtrace and see where it happened. So first error here, I think we've already kind of solved it, but let's go through the movement and see like what went wrong. So we have this code here on the JavaScript side, and this detection object is defined further up. Let me just show this as well. So these two lines here correspond to my Rust code, which has on this object here. So let's look at this for a moment. I have this tag here, wasm-bindgen, that allows me to expose it to the Rust side. And that allows me to import my bot detection here from my generated package. And here I'm using the JavaScript new keyword to create the object. To have that work, I need to do one more step. I need to write the constructor. So let me scroll down a bit and show this code here. This is the constructor, and you mark it as wasm-bindgen constructor. I've called it new here. You can use any name. The important part is you tell it this is the constructor. When JavaScript calls new, please call this code. So really, when we have this on this side, we go into the wasm-blend, into Rust. We execute Rust code. We allocate stuff on the Rust file. And then we somehow expose that over here. Now, if we scroll down, and sorry, I have to go back and forth between files to reset the highlighting. Didn't find a better way yet. But let me highlight this again for clarity. When I call detection.addEvent, this is the mouse movement event that goes in. And I have over here a corresponding method that I just define on in the input block of my bot detection. I have an addEvent function here. Pretty cool, right? You just add this wasm-bindgen here, and it generates everything. You can make this call. It works. You might notice that I've renamed it for how it should look in the JavaScript side. That's because we like snake case in Rust. JavaScript doesn't. I like to go with the conventions, so I usually add this kind of renaming on every function that has more than one word. That means I can use add event here in the camel case, and here it's snake's case. But if you don't add this specific name, it will just use the same name for both. And yeah, if you look at the function body, it creates an event object that's now defined in Rust, takes out the value from this mouse event. WebSys is another crate that's useful. So you can see here, event WebSys mouse event. They add all these other types that you might use in JavaScript. And you can selectively say like which one of these should be compiled into my Rust binary. Because you don't want all of them, but you want to have the option to just use already existing types rather than writing them by hand every time. But by default, you have like string and like a few very simple types, but mouse event is one that I had to pull in from WebSys. Then I can use it like this, very easy. And in self events, I push this event to the list, so I can keep the data kind of on the Rust side. And that's how things work here. Just to give you an idea of what kind of state we have, we should look at all these structs. So this is the one main struct. The way this usually works and the way I've done it in this demo is we have one object. We create it once on the JavaScript side, and then all the state lives in this. So we just keep this variable alive in a global variable in JavaScript, and we can always call methods on this thing. So all the events that we care about are stored here, and then we have saved results. I will come back to that in a second. Event is just two fields, a timestamp and a coordinate. Then the coordinate is just two numbers. And then this is again this output. So when I click the isBot button, it will call the isBot function, and it will generate one of these outputs. And here is a list of those. That allows me to show all the previous results in the kind of the demo. You will see it afterwards, but all the state is here. JavaScript just displays it. And inside the output is like a human score. How human do we think is the movement of the mouse? Timestamp again, and then the result text is just the text for representation for the human. Like it's basically robot or it's human. As you can see, if we go to the isBot function here, isBot human score. Don't worry too much about how we compute it. It's very safe and secure, and I don't want you to know because otherwise it will break my system. Result text here, maybe we need a bit more. That did work. How can I make this wider? Okay. This is wider, isBot. So this is just if human score smaller than 0.5 robot, otherwise human. This is a Rust string, and we expose it to the outside world down here with this getter function, or like this function here called text. We use a result text, we clone it, so ownership moves over to the JavaScript world, and then this is still a Rust string, but wasm-bindgen will make sure it's a JavaScript string. Okay. So far, it's a lot of code, a lot of stuff showing here. I could show more JavaScript code, like there's this update function that reads basically these three state variables. So we have the state stored in Rust, and like all the events copied again to JavaScript for easy display and the latest result. And then there's this update loop that is called in a request animation frame over and over. And these are all just DOM manipulation stuff. It's just like take the information, put it in the DOM. There's nothing interesting in here, just know it exists. The interesting code is, for example, how do we set this all events array? And we are setting it here every time we move the mouse. we are also updating, like, first we add the new event to this detection object, and then we read it back. So it's like we go into Rust, and then from Rust we read the full list and put it into this all events array on the JavaScript side. And the way it's done now, it's buggy. And we get this null pointer problem. And now the question is, why? And this one is a bit spoiled because I've already shown you how it's supposed to work. The thing is, I've called this events is a function, and I just forgot to call it. It's JavaScript. You can do that. JavaScript will not complain. And you might think, well, okay, events, I mean, isn't that a field here? Yes, it is a field here, but notice this is not public. If it's not public, it's not exposed. And if I try to make it public, then the cargo, or like the Rust-C, the compiler will complain and say like, hey, you cannot expose this directly. This is a vector. It's not copy. Like, I need it to be copy so the JavaScript can just grab it. If it's like something more complicated, I cannot just grab it. So yeah, this is not exposed, and I cannot just easily expose it. That's why I have this function here, very short function. Maybe we can just make it like this. This function here gives me the events. And now just to demonstrate if I have this the wrong way, what happens is I set all events to this function. I go here, I move around the cursor. Wait, I need to refresh maybe as well. Save this, all events, action events. Refresh. Yes, now it's the way. Now when I move it, events generated is stuck at 2. Like this shows the length of the array all events. And it's, if I refresh, it goes to 0. Now I move it, it's stuck at 2. No crash. Rust doesn't complain that we're just using this function as a value and even looking at length of that thing. So maybe we can log this. We're in JavaScript. It's easy to debug stuff. I could use the debugger, but let's kind of make it even easier and just console log all events. What is this thing?
Now your function call is gone.
That's how it should be. I want to show you like how when things go wrong, when you forget to call it, it's stuck at 2. So you can see we print it's a function, and if you open it, it has a field length, because that's how JavaScript stores a function. There's a length field telling you how many parameters you should give it. It's beautiful. It's like I'm printing the length, and it's like, yeah, here is the length. Okay, and now I click here, and it tries to make a computation over these functions, and it says like, this is not an array of events, it's an array of functions. So array contains a value of the wrong type. So like, you can start to see how it makes fun if you combine these two languages. You like the type safety, and then you have combination. But okay, that's easy. We go back to the solution. We give it a start and an end, and it will take a slice, make that a vector, and give ownership of that whole thing back to JavaScript. Good, fine, all happy. Now, I still have this other bug. So let me save this, hard refresh this.
So question, to vec is creating a new vector, right?
Yes, so it's taking a slice and allocating a new vector from it, yeah. So now I'm moving around here, and you can see it's correctly counting all these events. I can click here, and I still have some sort of null pointer. And this time, I think I haven't refreshed hard enough.
You need to make the network tab not cache.
That could make things easier.
No,
It's a bit annoying when it's so small
yes.
or big, when I see so little stuff. So this works, but this doesn't. So we still have a bug when we try to get the human score. So now let's see, where are we getting the human score? It's up here in the, when we set the inner text. So this latest result, now this one seems to have the wrong type, the wrong value. So let's see where we're setting this. So when I click on MIBot, I click on this latest result. And now we can print it here, like what is latest result after we've set it here. And I expect that this looks kind of fine here. So let's refresh this. Refresh again to be sure. Move around. Open the console so we see it. So we get this null pointer, but first we get an object here. And it's interesting. We have an object that's a web, like a wasm-bindgen pointer that looks like a valid number, and then we open it up and now it's 0. It's a bit sketchy. And it gets even sketchier if I copy this line from here down here. Now, latest result before I call save result and after I call save result. Now, what will we see? I click here, it crashes. Now, before it was a valid pointer, and afterwards it's 0. Now, you're all smart Rustaceans. I will show you the code for save result in the Rust side. And I'm sure someone in here can tell me what's wrong with this code. Why does my latest result that gets passed in this function, why does it get corrupted in this way? You only need to see these 4 lines.
It must be JavaScript.
It must be JavaScript, because Rust is perfect.
It is. No one shall move the memory of the buffer that's resizing.
The ownership is passed to the vector in Rust?
Yes. I mean, this is latest result, right? So this is just one, this is not even a vector, this is just one result. We pass it in here. This is a bot detection output. What does this signature tell me in Rust? I take ownership of that, exactly. This is mine. JavaScript gave it to me. It has no longer the right to use it. Next time it uses it, I will throw a null pointer exception, because this one, there's no longer ownership. So we change it to just borrow it. And I recompile it. I think I can just do it like this. Now I've done some unrelated changes apparently. Now I have to clone explicitly. Yeah, now Rust is helping me. And it runs again. So let's see if this helps at all. I mean, this is a network error. So I go here, I click, and it's no crash. It's like Rust borrows, it works, and it's the same pointer before and after. But there was no hint. There's no, like, how do you find that out? It's fun. It's fun. And now we can click a couple of times here, and like I don't want to like bore you to death with too many different problems, but maybe you can see problems on here. But at least now we can see we saved these different results, and there's the nice timestamp of today, the 7th of January 19. Wait. Anyone has an idea what could go wrong? Why is it the wrong timestamp? We put in the date here. This is the JavaScript code of, no, this is not this date. Here, add event of this date. And we pass around the timestamp. And
Seconds of milliseconds.
Yeah, exactly. Yeah.
so my timestamp is a U32. Is that good enough?
No.
It's a milliseconds timestamp. It's too small. Suggestions how to solve it?
U128.
U128. Do I need that to go that high, or let's see. So let's build it, and it says wasm-describe is not implemented for U128. So that's too big, but maybe we can try U64.
Okay.
That should be good enough. It runs. Okay. So we can try that. Yeah, I need to start this again. Now I have a new error here. Like, what's this? Uncaught type error. Can't convert big number to big int. So it can't convert a number that's too big for a U32 into U32 silently. Doesn't complain. But now that I gave it a U64, it's complaining like, I have a JavaScript number that's a floating point number that has more, that doesn't map well to a U64 because there are more numbers in the U64 than I can represent in the number. So, I mean, this way should be fine, but wasm-bindgen basically maps these numbers and says like U64, if you have that in Rust, it's not good enough for a JavaScript number. You have to use a JavaScript big int. That's the one for U64. Because it's the only one that represents all the U64s. But the other way around, it's just silent. So one way to solve it would be to now do all the explicit conversions to big int. Fine. But what I found to be the best solution, float 64. I mean, it's a bit weird for a timestamp, but the thing is, it's a JavaScript number. It is a floating point. Like, unless it's like a small int with the optimizations, whatever, it is actually a floating point. And now I click here, and I think this date looks better. So it's these small things. Now I have I saved the biggest, most cursed code of them all for last. And I think we can go for it. Do we have the time left for it? When does the organizers say?
Yes.
Okay. So, first of all, we can get rid of this console output. It's no longer necessary. We have fixed this one. And now we should try these buttons below here. So what happens is when I click jitter, it will give me the jitter number, kind of the raw output, so I can debug it. It prints it here. Good. Second button, it does the same thing, but before it computes the jitter, it will set all the x numbers. Like from the coordinates, all the x values will go to 0. This way I can kind of debug what happens is it necessary to use a 2D coordinate system, or will it work better with just one coordinate? It's just a toy. Doesn't help much, but the point is it doesn't work. It's kind of pretty much giving the same results. Like if I move just left and right, there's no x. If I said there's only x movement, so the number should be basically 0 when I press it here, but it's not. It doesn't really matter which one I click. And I will just give you like the very simple code that's going to be super annoying to see. We have this function that is called by the button. We loop over all events and we set the coordinate x to 0 to all of them. And I already told you I suspect it's not working, so let's see what this value is before. So like before setting to 0, this thing is this. Okay. Let me make that wider for you. And I do the same thing again afterwards. And we should be able to see exactly what's going on. And just double check, it's all events I coordinate x, like it's the exact same thing here that we just set to 0. We refresh here, I click on this button, and it's a loop through all the events, so you will see many values. But you can see it's always after, before, after, before, after. And it doesn't change. Before, it's 136, and after, we just set it to 0. It didn't change. Any guesses what's going wrong? Maybe while you think, I show you the code from the Rust side, because, I mean, here it's just an assignment. There isn't too much that can go wrong, you would think. So let's see. This is an event in an array of events. So this is the event. And then we have coordinate inside. It's just 2 numbers. Implements clone and copy. That allows me to make this publicly accessible. And that's all the code you need, just these 2 definitions. wasm-bindgen makes it simple for you. It's
modifying the copy.
It's modifying the copy. It is, in fact, true. You see what's happening in the background. It generates some code for us. So instead of accessing like a field, it will use the getter syntax of JavaScript. For the sake of time, I will not show you all that they generate the code. I will explain it in words. And there will be a blog post in a week or 2. Maybe you can read up all the details there. But in JavaScript here, it's a field. But then for the class, they defined a getter function for that field. Every time you read that field, it calls a function. That function looks up this wasm-bindgen pointer that we've seen and gives that to Java, back to Rust, and says like, please restore this object at this pointer. And then there is a wasm ref cell, which is just a normal ref cell with very slight changes, but it's basically copy-paste the code from the standard library ref cell in a RC, reference counted. And if you think about it, it makes sense. This thing here is a JavaScript object. You can easily copy it around. You can have it in event handlers and in different closures everywhere. Like once it's in JavaScript land, we should assume it's shared. So we need reference counting for the lifetime, and we need inner mutability because all of this copy could be changing it all the time. So wasm-bindgen is setting up all of this state management, the inner mutability and the reference counting. And now we want to access this field coordinate here, and it will say like, okay, I have this field. It's a function. This function, when I read it, will read this value, which is a reference counted thing. I will copy that for you. Here is a copy of it. And then I say, okay, from this copy, I want the x value and set it to 0. Like, okay, I take the copy, I set the x of that to 0. What happens next is no more pointers to that copy are around. JavaScript garbage collector will clean it up, Rust will clean it up, and we're left with the original unmodified event. Exactly what we wanted. How can we solve it? Now, for this, the easiest way to do it is basically, I will keep the wrong line for now and just kind of solve it down here. We can say the coordinate here can be a new coordinate, and now we're calling the constructor on the Rust side, and you can see I get auto-completion because wasm-bindgen gives me the TypeScript definition. So it's actually quite nice. So I get the feeling of type safety. I feel it's safe. I can say x is 0, and for y, I will use the old value. When I read the old value, I don't care that I read a copy. It's the same value. Reading, it's fine. It's only when you modify it that you get this weird copy on the fly. So I do this, and I delete this line or just put it away. And this works. You can. Now it's instead of a getter function, it uses the setter function, and that will overwrite the value. That's fine.
It doesn't copy the whole thing, the whole coordinate vector?
This is a JavaScript array. A JavaScript array of wasm pointers.
Okay.
Yeah. In the blog post, there will also be one where all those pointers will be null pointers. It's fun. You have a valid array of nulls. Yeah, it's fun.
It's type safe.
But this is basically the last one. Now you should see that if I move it all around here, like jitter and setx both give us high numbers. But if I just go back and forth, because it only uses like the last 100 events, I click here, it gives me like a semi-high number. If I click here, it gives me like a basically 0 here. So now the x value was changed. And I mean, maybe the syntax isn't as nice. If we compare the two, this looks nicer, but this one works. And that's what I call cursed Rust. And that's my talk. Thank you for listening.